Greetings, ladies, gentlemen, and anyone in between. My name is Chris or Michael, but today you may call me John Dalton. Now, what I'm going to be talking to you guys about today is the atomic model. Now, the atomic model is basically what is used to describe how an atom looks or how the structure of it is. If you see a drawing, it's based on a model. That's the sort of thing. Now, of course, the model has changed over the years, and we are going to call that. But first, let's start with the origin of the atom, and that being atomos. Now, what atomos means is basically indivisible, because at the time, the person that theorized about them, that being Democritus, back in 430 BCE, aka before Common Era, or if you are religious, BC, before Christ, he believed that atoms were indivisible, that you could not simplify the atom or divide it into separate things. And he believed that atoms were made out of the four elements, those being earth, fire, air, and water. Now, of course, his idea was largely ignored at the time, and it wouldn't be until over 2,000 years later that his idea would ever come into conception. Is that a word, conception? Probably not. So why don't we talk about the first actual atomic model, that being the Dalton model, created by John Dalton. It's fine. Of course, John Dalton made around 1803 CE, Common Era, or AD, and basically this is what he saw as it, because truly at the time the atom was just a building block, right? A brick or something, where honestly it could be anything. For example, AU and HE, for example. These are two examples of atoms. As you can see, the only difference will be that depending on the element, that one will be smaller than the other. And he believed that elements of the same type would look the same. Now, of course, that was wrong, but we'll get to that in a model where that part actually matters. And so, after that, we have the Thomson model by J. Thomson and Lord Kelvin. Now you may be wondering, who is Lord Kelvin? Well, Lord Kelvin is the person who came up with the model. He is also the person behind the Kelvin unit that you might see, which is also known as absolute temperature. Now, of course, something interesting about Lord Kelvin is his last name is also Thomson, hence why it's called the Thomson model, although you may also know it as a plum pudding model. Why is it the plum pudding model? Well, let me show you. Now, of course, as you can see, the plum pudding model basically suggested that it was comprised of two things: the center, the main core of it, which was a positive charge, and it having electrons sprinkled around it. What, as I'm not calling this a proton, because at the time protons were not really known, or at least not called protons themselves. It was really just an idea named plum pudding because it looked like plum pudding. And so yeah, as you can see, they started to show a more complex side of not just the models, but also introduce the electron, a very important thing that has come from the atomic model and has been used ever since. So next up is the Rutherford model. Give me a second. Ernest Rutherford. Ernest Rutherford. Now, of course, he is from one of the most recognizable ones, at least in media. It's as simple as, and then the orbits with electrons around it. Now, of course, the reason why this was made is because they were doing alpha particle testing, and they discovered that when used on a gold seed, um, that some particles will go straight through it, but some will be reflected, which was weird. So they theorized that there must be a core and a bit of empty space around it, hence why there's electrons orbiting around the central core. And as you can see there, I've represented with a node positively charged core. I've seen places that say that the core will be made of protons and neutrons at the time. However, I cannot confirm whether or not neutrons and protons were discovered at the time, or at least not neutrons. But this is truly the biggest step towards the most common, the most modern model, because now we can see that the electrons are orbiting around the positively charged part instead of being a part of it. And of course, the next part is probably the most common one, at least in school, and that is the Niels-Bohr model or Bohr model. Now, of course, you'll know it because it not only is comprised of imagine that to be the core, a poorly drawn core, but still. And as you can see, the black dots are neutrons, the red dots are protons, and these parts here are indeed the electrons. Now, of course, as you can see, here you can also see electrons orbiting around the center, but at this point they're much more organized. Now, the reason why is because hold on, give me a quick second. I'm so sorry. Because due to the electromagnetic theory, it would be much more stable for it to orbit around the center like this instead of how Rutherford saw it, because with Rutherford's model they will eventually lose energy and collapse into the nucleus. And this is the most common one you'll see. And in fact, if you ever taken a chemistry class, you most likely use this model for exercises. This is the most simplest and the easiest to understand. Now, if you are really well versed in this, you're probably assuming that the next one would be the most modern one, but in fact I have one that I think is a bit more important that I want to talk about, and that is the Bro yeah, the Broglie. I'm so sorry, Louis, but this model is a weird one. You can't find it easily, but you can find it. It is a model between the Bohr and the next model, and basically, so we've seen them like this. So let's say they're on their side, and this is an orbit, right? Well, the theory is that the electrons would orbit around like this. As you can see, they did not go in a straight line like a regular orbit, but they were moving waves and acted as waves. Now, huge thank you to Libretexts, which I had to use to get more information on the Broglie model, because even I took IB chemistry and I didn't really see it much. So thank you, Libretexts, for everything else. I used Britannica, which is a good source. I would have just done it off my memory. However, I wanted to make sure that you guys had the proper information and wouldn't just go off that. And that's my recommendation. If you think something's a little off, do your research. And of course, finally, there's the Erwin Schrödinger. Let's see if I get this right. And before you ask, yes, it is this Schrödinger that you're thinking of. And basically, it's kind of hard to show how it looks. So I'm just going to do a very simplified thing, and I've seen a lot of. So I'm so sorry, I'm terrible at drawing. But basically, the idea is that at the center we have the, the neutrons and the protons, and this will be an electrical field where the electrons could freely move around. And as you can see, this kinda is the evolution from not just the Bohr model but the Broglie model as well. And basically, this is the most accurate but the most complicated one, because not only do you have to worry about where the element is or how many electrons it has, but you also have to worry about hybridization, which is a pain that I to this day do not understand. I passed my IB test with pure luck because I have no idea. But then again, this video is not for that. This video is just to inform you of the evolution of the atomic model and to give you some basic information about it. Yeah. This video isn't that good. My sincerest apologies, really. This is my first video like this. I've done one before, but that was cut up into different pieces and sectioned back together. And I hope you enjoyed. My sincerest apologies again. If you have any questions about the atomic models, please let me know in the comments below, and I will happily answer those questions truly. I'm not exactly the best at talking in front of things, including the camera, but I have to get practice. I do want to become a chemistry teacher at some point in the future. So yeah, if I keep this up, next video should be about the atom itself, and more questions about not just how about. Let me erase this real quick. It's going to include information about the atomic weight, charges, isotopes, and stuff like that. Isotopes. Yeah, truly. So yeah, once again, if you have any questions on the atomic model, leave them down below. If you have any questions for the next video, as long as they aren't about hybridization and stuff like that, leave them below and I'll make sure to include them. Who am I kidding? No one's watching this video before then. Alright, bye.